In this Math Rescue video, we will be looking at how to prove trigonometric identities. Most students find proving identities very challenging. They are possible though, and hopefully this video will help you feel less intimidated by identity proofs. The most important and helpful advice I can give you is that you need to learn the basic trig identities. I promise that knowing these will help you work these problems more easily and more effectively. I've created a Google document that you can print out or save on your computer with the identities. Here it is on the screen now, and there will be a link below the video and in the video to the page where you can print or save it. It may seem impossible to memorize all of these, but you can do it. The best way to remember them is to use them. Work problems and try not to look at the identities. Only look at them if you get stuck. The second thing you need to do is find out which identities you are required to have memorized for your test or exam. Ask your instructor which, if any, identities will be given to you. Take the time to study the ones that will not be provided. Make flashcards or just write them down over and over again without looking until you can write them perfectly. Throughout this video, I will assume that you have the identities available to you. Now let's talk strategy. The goal with these problems is to use identities to get the two sides equal to each other. The best way to do this is to pick one side and work only on that side until it is equal to the other side. If you get stuck, start over with the other side. Don't work on both sides at the same time. While this may be quicker on some problems, it can get you very confused on others. So how do you choose which side to work on? Here are the things I look for. First, complexity. It is easier to simplify than to complicate, so consider the overall size of each side, and you'll probably want to start with the bigger side. Second, fractions. I think it is easier to add or subtract fractions than it is to split a product of fractions. Third, reciprocal functions. I sometimes call these secondary functions. They are the cotangent, cosecant, and secant functions. All of these can be rewritten in terms of cosine and sine, so the side containing these functions will be easier to simplify than the other. The tangent function can also be written in terms of sine and cosine, so look for that too. And last, binomials. Remember that binomials can be FOILed. It is easier to FOIL a product than to factor a trinomial. Here are a few examples. In the first example, the left side is more complicated and also contains a fraction. In the second example, the left side has fractions that are subtracted, while the right side has a product of fractions. I would prefer to work on the left side. And in the third example, the left side is more complex and also contains reciprocal functions and the tangent function. Let me show you how I would work some problems, and that should help you get started on your own. In this problem, I would choose to work on the left side of the equation because it is more complex and contains a fraction. Can you see what I mean about it looking bigger? You should notice that the numerator is a difference of two squares, therefore it can easily be factored. After factoring, I can simplify and end up with the right side of the equation. This proof is complete. Here's another problem. I've chosen the left side again because it contains a difference of fractions. I prefer to add or subtract fractions rather than to split a product of fractions, which you would have to do if you worked on the right side of the equation. In order to subtract these fractions, I must first obtain a common denominator. Once I've subtracted, the proof is complete. Here's one final problem. I'm working on the left side because it's more complicated, contains a fraction, and contains a reciprocal function. Anytime you have reciprocal functions or the tangent function, your first step should be to rewrite all these functions in terms of sine and cosine, which I've done. Next, simplify the left side. After simplifying, I need to divide fractions. To divide fractions, multiply by the reciprocal of the denominator. And that completes the proof. I hope that this video has helped you feel more comfortable with proving trig identities. Below the video, you will find a link to the Google document where you can print a copy of the identities sheet at the beginning of this video. You'll also find a link to the blog post I wrote that details this proof process and contains a few more examples for you to consider. If you like this video, please click like below, and if you want to see more videos like this one, please subscribe. Thank you.